So it's the same 4 steps. We're going to multiply across the bottom.
Mm-hmm.
That'll give us 15.
Mm-hmm.
Then we're going to multiply that direction.
Mm-hmm.
And that'll give us 5.
1, 5.
And then we elevate the sign to remind ourselves what we're doing. And then we multiply that way. Get 6. Whatever those 2 things say goes right here.
12.
And there we go. So I'm going to draw one up real quick. Let's do 1/4 plus 2/3. All right, same 4 steps. Okay, I'm going to change my pen color. We go across the bottom. So that's 12. Then we go up here. That's 3.
Mm-hmm.
We bring up the sign,
Mm-hmm.
plus, and then multiply that way, and that is 8. 3 plus 8 is 11. And that is how we do it. Those same 4 steps. Now, at the end, like I said, there's going to be lots of times where we're going to have to reduce this fraction and change it and all sorts of stuff. But 11/12 and 22/24 are, both technically correct. We would just have to do a little bit of reducing. So now we're going to do a little practice. There we go. That is addition in fractions. We want, now again, there's going to be a time where we're going to mess with these things and we have to fix these things at the back side, but that's the operation. Now, here's the cool thing about subtraction. Now, I shouldn't say cool, nothing's cool about math, but the difference between adding and subtracting these fractions or any of these fractions is almost nothing. So I'm going to wipe out these answers just for a second. If all of these questions were minus instead of plus, none of those numbers would change. So 2/5 minus 1/4, the only difference would be we would lift that sign up there, and 8 minus 5 would be 3. If this was 1/4 minus 3/5, all the math stays the same. It would still be 20. That would still be 5. That would still be 12. The only difference is when we lift the sign, we'd be getting a negative number. 5 minus 12 is -7. We can type this stuff into our calculator if we want. This would still be 15. This would still be 6. If this was minus, then that would be minus. 6 minus 5 is 1. So I'm going to put some more examples up there, but they're going to be written as subtraction instead of plus. And it turns out to be the same 4 steps. And there's nothing wrong with a negative fraction. And always the negative number goes to the top number. But here we go. Let's practice a few. So we want to feel confident about this. Same 4 steps. We're just subtracting now. That would be 20.
20/11.
This is 15. We lift up a minus. That's 4. So 11/20 right there.
Mm-hmm.
Should be 12. That's 8.
5/12. 5/12, yeah.
12. And then
And
15,
7/15.
12 minus. There we go. So sometimes it'll be a negative number like it was that one. That's fine. Sometimes when we get a decimal or a negative number or something like that, we feel like that can't be right. Like all numbers have to come out cleanly, but negative numbers and numbers too, and all that stuff. So we're going to work on what happens, how to deal with these fractions another time. But we just tore through addition and subtraction in a few minutes. And now we're going to do multiplication and division, which are even easier. Okay, so adding, we just go across the bottom. Up here, 15. Elevate the sign, plus. Multiply here, which is 4. Whatever those two things turn out, that's where we put our answer. Again, this may need some work. That's adding, so we can feel good about that. Subtracting is the same mechanics. The only difference is if this said subtract, then when we elevate the sign, all the numbers stay the same. So 15 minus 4, that would be 11. So that's subtraction. Now we're going to talk multiplying and dividing. Multiplying and dividing. Oops, didn't want to do that. Multiplying and dividing is, let me see how cleanly I can do this. That 15 is going to have to stay. Let's see if I can cover that up real quick. There we go. Getting nifty with this. All right, we're going to edit all that out. Okay. Multiplying is fairly simple. We multiply across the top and multiply across the bottom. So that would be 3, and this would be 20. Odds are we're going to have to massage and work this around a little bit, reduce the fraction, all that other stuff. We're going to work on that later, but we just want to tear through that. That's all multiply is multiplying across the top and multiplying across the bottom. And division, if this was division, then all we got to do is think, man, I'd much rather multiply. And math says you can. We're going to keep the first fraction the same, change this to multiply, and flip this one upside down. And now we just do what multiply says. So that's the old keep, change, flip. We multiply across the top and we multiply across the bottom. And almost always we're going to have to do something with that fraction. So 15 over 4, this is an improper fraction. We would have to change this to a mixed number. That's fine, but this is still technically correct, not written in its best terms. So that's all for. We're going to go practice some multiplying and some dividing on the old whiteboard, but that's a completely different way to look at fractions. And no matter how complicated they get, it's always the same operation. Okay, so we multiply across the top. We get 6, 12, 2, 20, 6, 15. Now, all of these answers have to get reduced. And that's fine. And we're just going to do a quick version of it right now. First thing is just look, is the top number bigger than the bottom? And you want to think about it like you're stacking a bunch of trays with dishes on it or something like that, that you wouldn't put all the heavy dishes on top. So we always, no, we want the firm base that's the bigger number. And we're good here. The bottom number is smaller than the top number, which is cool. Next thing we look at it and go, are they both even numbers? That's an even number, that's an even number. At the very least, you could cut them in half. Cut 6 in half, cut 12 in half. And now we got halfway there. That's fine. So we're gonna do that. Okay, we do that. Okay, cut those both in half. 1/10. Can't cut those in half. Next thing you quickly ask, are they divisible by 3? And these are divisible by 3. 3 goes into 3 once, and 6 divided by 3 is 2. And if we had done real quick, that's 6, that's 1/2 of that, fine, go there. But quick steps is the top number bigger? Are they both even? And then we look for 3s. So this is good. This is as low as it can go. These we couldn't reduce because they're both even, but we want to do the 3 check. Can 3 go into, well, 3, 6. Yeah, 3 goes into 6. And if you ever want to know if a number is divisible by 3, just add the digits together. And when you get whatever you get as a sum of the digits, if that number is divisible by 3, then that number is divisible by 3. Now, 6 isn't the answer, but it's a quick little indication of, is this thing divisible by 3? So it's worth a try. So if you divided this by 3, 6 divided by 3 would be 2. And 15 divided by 3 would be 5. So that would be how we would reduce that. But that's not, this part isn't multiplying fractions. This part is, and that's our goal, is to say handling fractions for this part is a piece of cake. If we get to an answer we have to work with, we'll get better at that, and we'll nail that down. So here's what the next goal is going to be. Divide these, and remember, it's keep, change, flip. So we keep, change, flip. Move that down so you can see it better. There we go. All righty, and we'll pause. So all I did was keep the first, change it to what you want to do, which is multiply, and then flip the other fraction upside down. And it's back to just this: multiply top, bottom, top, bottom, top, bottom. And then we'll see what we get. Now, when we divide, we almost always have to work with the answer a little bit to adjust it a little bit, but that's no big deal. Okay, so we get 9 over 8, 8 over 5, 9 over 10. When we go through our quick checks, now, again, our goal for this drill, this assignment, is to work on adding, subtracting, multiplying, dividing. But we're just going to peek ahead for a second. If the top number is bigger, and that's our first question we ask ourselves, all we do is we say, how many 8s can I pull out of a 9? There's 1 in there. So if I ask myself that question, how many 8s can I pull out of a 9? If I have a box of 8 apples, going back to old school math, how many groups of, what I say? If I have a box of 9 apples, how many groups of 8 can I pull out? 1. So that's my 1. And then if this is a 1, we can just subtract that and say, and there's 1 left over. The bottom number is sacred, so that's not going to change when we convert that. Same thing here. I got 8. How many 5s can I pull out of an 8? 1.
1.
How many leftovers? 3. And the bottom number is sacred, so that stays. So 9/8, I can pull out a 1. There it goes there. And then the remainder goes here. 9/10 is fine the way it is. So that's a quick talk. This is called an improper fraction. That is a mixed number. Of the two, this is the more preferred way, or the formal way of writing the fraction. We don't have to worry about that right now, because what we just did is conquer addition, subtraction, multiplication, and division of fractions in just a few minutes. So we're going to drill them another time, but for now, let's feel confident that we went flying through that pretty well. So this is how we're going to end this little section, is that we're going to take these two fractions and add them, subtract them, multiply, and divide them. Okay, so if you're watching this tape or video, just pause it and try to do all four. Okay, in the meantime, now I'm just going to zip right through them. If we were adding, we'd get 13/12, which we would reduce to 1 and 1/12. So that answer, let me get rid of all this stuff, is 13/12, or if we're feeling advanced, 1 and 1/12.
Mhm.
Next, subtract. Five twelfths. Next, if we were multiplying,
Mhm.
if we were multiplying straight across, 3, straight across is 12. It'd be 3/12. They're not, the top number is not bigger than the bottom number, which is fine then. Are they both even? They're not. Can 3 go into both? Yes, they can. So we're going to divide by 3. 3 divided by 3 is 1. 12 divided by 3 is 1/4. That's reducing. No big deal there. If we were dividing, we do keep, change, flip. We keep 3/4 the way it is.
Mhm.
We change this to times. We flip this over real quick. And now we multiply across, top and bottom, 9/4. That is technically a correct answer. It's an improper fraction. How many times does 4 go into 9?
Two.
Yep. So this is like when we kick that number like that, it's just a quick division problem. 4 goes into 9 2 times with a remainder of 1. So there we go. So there is a little bit of work at the end sometimes, but the adding, subtracting, multiplying, dividing, that's in the bank. So think differently about fractions. This is how we win, is we look for change, and let's change the way we think about it and go, I can handle fractions however they throw them in.